Hi, and welcome to Chapter 9. In Chapter 9, we're going to introduce you to servers and different types of server types that you're going to be using in your networks class. Let's get started. So first things first, let's look where we are in the book. As far as operating systems, this will be our last chapter. We're kind of including it in operating systems, even though we're not really talking about OSs in this lesson, but servers as a device and the way that the way that they work with your machines. As soon as we get through with this, we'll start working on TCP/IP and different transmissions. So let's start by describing some different types of servers and services that you can offer. Each of the different servers can provide a different service. So we can have a server that is specifically dedicated to authentication or security. We can have a database server. We can have a web server, a mail server, and a print server. We can have each of these servers as individual devices or thin servers, where that server is only useful for its purpose. So we can have a thin server that's a web server, and its entire purpose in the world is just to handle web traffic. And that's all it does. It doesn't handle your email. It doesn't do any printing. It's just your web server. And we can call those thin servers, ones that only have the hardware and software for a single function, specifically, in this case, a web server. We can also obviously have multi-function servers, a singular server that can do multiple functions. You can have a server that acts as both your web server, your mail server, your print server, and your database server all on the same device. This is usually used in smaller networks where the amount of traffic going to the server is small enough that each one of those traffic sources can hit the same server and it's not a problem. If you have a situation where you have a website, for instance, and you're getting a huge amount of traffic to the website, but your personal email and your print server and your database server isn't that important. Those can kind of be all on one multifunction server, and then you have a web server separately. So you have options of splitting around your servers, deciding how you want to handle them. Each of the different servers can be classified by their number of CPUs. So we can talk about a server being able to have multiple CPUs, singular CPUs, being able to do different types of processing. And we'll get into that a little bit more as we continue discussing different types of servers. So obviously a server needs to have some way to start, and we can talk about the server case as the different ways that servers can be defined. They can be in a rack or a rack mounted, as it is listed here over on the left-hand side, or we can have a blade server where they're put up in blades and you can have them kind of going around in a circle, individual servers working together like that. A lot of times when you have multiple servers, you're going to want to put them in a rack for obvious reasons. You don't need a full tower for each server, like sitting next to each other. Put them in a rack and it makes things much easier. When you do it this way, you generally have a motherboard sitting at the bottom attached with a power supply, and then a couple of other basic components. We call a simple motherboard a backplane, and this backplane is just the basic minimal components that your server needs to run. You would need to have some fans, you'd need to have an I/O board, you need to have a couple processors, you need to have some memory. And that's about the minimum of what needs to be there when you create a motherboard. Obviously, you can add more to it, but the basic motherboard with just the simple components, we call a backplane. Obviously, you need to have power supply attached to it and so on and so forth. The backplane with the modules and the I/O board, you can see just kind of fills in a little bit different, but it's still following the basic concept. I/O, processors, memory, and fans, because you need fans to keep things cold. Even though in Montana, we like to keep things cold. Obviously, you need to have power supply. You got to get power to it somehow. So basic things, you need your motherboard, you need your power supply. Your basic I/O, or your basic input-output, or your BIOS, this is going to be the firmware that is designed to work on your motherboard to start it when you turn the power on. Your BIOS is going to handle running your starting your operating system for you and running some basic post tests. We call them posts, power on post test. And they're the tests that just make sure your devices are working correctly and everything is still good and your hard drive is there, and go ahead and start the operating system and move forward from that. So you need to have these kind of things in your BIOS with your basic motherboard. So your I/O board connector is going to hook up there. And obviously you need to have a processor, so your CPU. If you have multiple processors, you could have what we call parallel processing, which is where each of the different processors can work independently and run in parallel. to allow things to go faster. And one of the more important things to think about when it comes to your server is whether or not it's hot swappable. Hot swapping or hot swap allows the different components to be removed and replaced while the power is still turned on. It's hot. It's got electricity going to it. So if I have 4 memory slots and I need to replace a memory and it's hot swappable, I can pull the memory out, put a new one in. The other 3 will continue to work normally, and it works just fine. Same concept with our processor or our fans or anything like this. If we have parts of this that are hot swappable, such as, say, the hard drive, if I can pop out the hard drive, pop a new one in while it's still running, I don't have to worry about my server shutting down and denying everybody access to the server while I'm making that change. So we really like to give the opportunity of a hot swap in our processor or in our servers to allow us to make those changes without having to shut it down. One of the different hard drive options that you have is called a SCSI. Yes, it's pronounced SCSI, SCSI, or a Small Computer Systems Interface. SCSI drives are actually able to be chained together so that we can have multiple drives, and as we need to add new drives, we just plop another drive in there, and they can all work together. So we use SCSI drives a lot, and there's a lot of different designations in those. So we have the designation of it being wide, which means it has 16 bits for data transfer as opposed to 8. So a standard SCSI usually uses 8. Wide uses 16. We can also have a fast or ultra. So fast being an increased over basic SCSI, and then ultra being faster than fast. So the next level up, increased in frequency. And you can see the speeds and the megabytes per second here in the chart so that you can see that. So you can see the wide allows 16 devices instead of 8 because of that 16-bit data transfer, because the bus width is going to be 16 bits. And so that's how you can kind of remember those. Wide is going to tell you that 16-bit. When we have our SCSI, there are 8 bits. The first and the last are usually used for information. So we really can create 0, or actually the last, the 7th. So we can add extra SCSI drives on at 0 and through 6 bits. So we can have 6 devices attached. And the basic PCI slot plops in there. We have an adapter, and we go to these multiple levels, and each of them can connect together. So when you think of SCSI, I always like to think of it can be multiple, like multiple cards all put together. You can keep adding new ones as you go along. So we have an ID number that defines which drive we're referring to. And then we also have what is called our logical unit number, or our LUN or LUN ID. Because of the way that SCSIs are designed, you can add extender cards to the bit locations. So I could put an extender card at position 0, or I could put an extender card at position 6, and then put an entirely new 7 drives onto that as well. When we use an extender card, we use that LUN identification number, so that logical unit number. So we could say go to 6 and then whatever LUN number it's at. So SCSI 6, LUN 3 would be the LUN number that goes with the extender card that is attached at SCSI position 6. We also have the image here of a serial adapter, or an SAS, so serial attached SCSI, as opposed to a SATA attached. And you can see they're both very, very similar. And these can be used in a serial port as well. So you can use the serial port there for your SCSI attachment. Excuse me. Nice thing about SCSIs is that they're also hot swappable. We can be able to pull them out, put a new one in without having to shut everything down. They're allowed to continue their usage as they go along. So as I said, you need to have some power. You can't have a motherboard, you can't have a server without power. The automatic configuration power interface, ACPI, automatic configuration and power interface. This is the standard for controlling power options. And as you probably know, on your laptop or your desktop, there are options that you have to control the power. What do I want to do when I close the lid? What do I want to do when it's been 4 hours? How long until I shut down the machine because it doesn't have any power? What do I want to do on power? Do I want to have power, maximum performance, minimum performance, so on and so forth? So ACPI is the acronym for your power interface. Try to remember the P part of that, the power, because it controls your power options. The ACPI component architecture is the ACPICA component architecture, and it's an extension to the ACPI that's non-proprietary, open standard that helps with the interface options. So most computers are going to use some version of ACPICA, the component architecture, to be able to keep track of their power. A couple of system resources, and these are really important in even your regular computer, but they're very important once you get into a server to keep track of your resources. So starting with our IRQ, which is our interrupt request. So I for interrupt, RQ for request. When we have devices, each one is assigned to a specific IRQ number, and that will communicate directly with the CPU. If that device needs to tell the CPU something, they're going to use that IRQ to be able to communicate. You can go into your device manager and look up any of these. So these are all inside of your device manager, and they reference just different ways that the system keeps track of things. So your IRQ is an interrupt request to communicate with your CPU, your processor. Your DMA is your direct memory access. It's a channel. And it is similar to an IRQ, except that it communicates with the RAM. So it communicates directly with your memory as opposed to your CPU. It doesn't have to go through the CPU. It can go straight into the RAM as opposed to go to the CPU and tell the CPU to do it. Generally, this works with your motherboard chipsets, your BIOS, or your CPU. So it works with all of them kind of together. This is your DMA, your memory access directly. We are direct memory access. Obviously, I/O is important. You're going to hear I/O a lot. Input, output port. So your I/O port is going to hold very small amounts of memory that is assigned to each device that they can use temporarily while they're waiting for data to move around. Just like, here, hold this for a second. I will deal with you in a minute. I just need you to hold this one little piece of information, and then I'll be able to move on. So your I/O port holds a very small amount of memory. Your MAA, or your memory address assignment, holds very large blocks of memory that each device is given for its data transfer. So depending on the device, you may have larger blocks of memory because it may need it, depending on which devices are attached. And these are the different device manager things that you need to keep track of for your system resources inside of your server. So I/O, small amounts of memory, memory address assignment, large amounts. IRQ goes to the CPU. DMA deals with the RAM. So try to keep those straight as to which resource deals with which part of the computer. So we're going to introduce RAID systems here. And you may have heard about RAID systems, the redundant array of independent disks, or as some people call it, of inexpensive disks, because you can use cheap disks for this. You don't have to have very large, very expensive disks when you have a RAID system. There are multiple levels of RAIDs, so we can start with the basic level of RAID. Each of the different levels has different things about it that make your RAID system useful. The first one, RAID 0, does not actually have any fault tolerance or ability to recover from a hard disk failure, but it does help speed up sending information because it uses what's called striping or stripping, depending on how you want to pronounce it. When you do this, you separate the data into multiple sections, and then you write it to different hard drives at the same time. So a little bit in this strip, a little bit in this strip, a little bit in this strip, and they all go to different hard drives. So because of parallel processing, I can process the same amount of data in, say, a third of the time by having 3 drives with disk stripping. So being able to have the different data in different sections. That's a RAID level 0, and there is no fault tolerance at RAID level 0. A lot of people use RAID drives because of their fault tolerance. Fault tolerance simply being the ability to recover from a failure if one of your hard drives fails. Well, if you have all the different stripped in multiple locations and one of the hard drives fails, you can't get that back because there's no duplication of data anywhere. One of the things that we add is mirroring. Mirroring is writing the same data to more than one drive. This starts to get to be fault tolerant because if I have 2 drives and they have the same data in them and one drive fails, the other drive's still there, I'm good. I've got fault tolerance. So your RAID 1, which gives you mirroring, allows you to have fault tolerance to be able to recover from a hard disk failure. RAID 1 also sometimes includes what we call duplexing, which is mirroring, but putting them on different hard drive controllers. So each controller controls a different hard drive. They're separated so that if one fails, the other one can still be used. So your basic RAID 1, level 1, is probably one of the more common. It isn't very, very expensive, but it does allow you to have multiple drives with fault tolerance. When we get into RAID 2, which is not used as much anymore, we used an error checking code, but it's kind of redundant with some of the ways that we use parity to be able to get information back. So a lot of people don't use 2 anymore. 3 and 4 both use striping with parity. So parity allows the data to be recovered on one drive by storing all of the parity on a singular drive. So we have an entire drive that is all of the binary code of an entire data pattern. Because it's stored separately, again, that means that if you have failures, you can recover the data using that. So RAIDs 3 and 4 use that. RAID 5 is probably the second most common after RAID 1, which allows block level striping and distributed parity. So we allow that parity to be able to recover it, and we have that striping so that things go really, really fast. Obviously, we can also have RAID 6, which is dual parroting. We have a RAID 01 or 05. One has mirroring and one has striping with parity and striping. So lots of different options here. I would say for the network test, you want to remember RAID 0, which does striping and is no fault tolerance. RAID 1, which is mirroring, fault tolerance, and RAID 5, which does striping and parity. So these are the different ways that you want to remember your RAID system. So your high-end servers with that block level striping is going to help you. The difference between block level and byte level is how it's the data broken up. And these are all obviously explained a little bit better in the book. So I want to make sure that you understand the different levels and trying to understand why would you use one over the other. The important thing to remember with RAID systems is that fault tolerance, the ability to recover from a failure, the ability to have duplicate data stored in a way so that you can access it easily in the case that something goes bad. All right, there are 2 different types of storage systems that we talk about at this point, and it's hard because they are the same letters flipped around, and a lot of people get these backwards. So our network attached storage, the last word is storage. It's a device that provides storage, so it's a drive or a disk or a tape, and you can log into it via a client. It is an actual device that does the storage for you. So if I wanted to take my data and put it in a place that I could then access via a client, I would use network attached storage. It uses the network to get to it, and the storage is sitting over in the other place. A storage area network is an actual separate high-speed network that connects the regular network to the storage facility. So the network itself, ending with an N, ending with the word network, is your storage area network. The storage itself, where data is being stored, would be your network attached storage, NAS versus SAN. So SAN is the network, the cabling, the thing that creates the network, as opposed to the storage, which is the actual disk drive. So your storage area network usually uses something we call a fiber channel, and we'll talk about that in the next slide. Okay, so your fiber channel is a high-speed access method, usually with a fiber optic, designed to work with your storage area network. So the fiber channel has a series of standards and protocols that define how the fiber channel is going to be used. Using the Network Address Authority, the NAA, the standard that was developed by the Information Technology Standards, ICITS, usually starts with an NAA dot and then a series of numbers to describe the addressing. There are 3 different ways that we talk about our fiber channel. The first is a basic point-to-point. 2 stations connected by a singular line. It's a point-to-point, one to the other. It's just a straight connection, and if that connection fails, you can't get back to it type thing. It's not a loop. It's not a mesh. It's a single channel that is defined to get from data from one point to another. So that's point-to-point, which kind of makes sense. 2 points goes from point to point. An arbitrated loop technology is similar to what we had for a token ring, but it's limited. You can only do 127 connections because you start bumping up against naming. So in this case with a loop, the example here where we have station 1 connected to 3 and 2, but not to 4 because we can go around the loop if we needed to get over to 4. And probably one of the more common ones is what we call a fabric switch topology. So this uses a device called a fabric switch to handle being a hub in the middle of your network. So all of the stations connect into it and allows it to be switched using the fabric switch topology. So using a fabric switch is a way to run your fiber channel. InfiniBand is another version of this that's actually designed to compete with the fiber channel, so you can use InfiniBand as well. We don't really get into that because we've described the fiber channel, but it is another option that you probably should be aware of. So we talked about SCSI drives a couple of slides ago. Now we're going to talk about the Internet Small Computer Systems Interface, or iSCSI. Yes, that's actually what it's called. So it's an Internet Small Computer Systems Interface, or iSCSI, SCSI for SCSI. It was developed by the Internet Engineering Task Force, designed to use with tapes or disks or storage arrays, and it works directly on your network, on your LAN or your MAN or your WAN, using your basic IP4, IP6 addresses. The nice thing about the iSCSI is that it actually is a little faster, longer distances, and less expensive than just doing a fiber channel. So we can use the Internet Small Computer Systems Interface to be able to combine different drives and networks together. The initiator, or the iSCSI initiator, makes a request to the target using either its iSCSI qualified name or its enterprise unique identifier. So the iSCSI qualified name is a specific location for a specific iSCSI device that says, I am an IQN, an iSCSI qualified name, IQN, and then we usually give it the month and year that it was created, who the authority was that created, and then some sort of a unique identifier for the name. Specifically, I put in C. Simpson or CSIMP7 netlab domain.local or something along those lines. And this is the initiator name defined to a specific location. You can also choose to use the enterprise unique identifier developed by IEEE using the IEU and then a series of hexadecimal numbers. It isn't as easily identifiable because they're hexadecimal numbers, but it does give you a unique identifier for a given location. We've talked a little bit about virtualization, but we're going to bring it up again. Virtualization is simply creating a software based on a virtual environment. So we're going to be using a virtual environment to run our software. In our case, our server or our mail server or our database server, whatever we're going to be doing there, we can do those in virtualization. With the advent of the cloud and things advancing in that direction, a lot of companies are moving away from having the server in their local location and having it in the cloud in a virtual location. They don't have to worry about power outages. They don't have to worry about someone breaking into the building. They don't have to worry about purchasing the software or purchasing the hardware. So that's really useful. Oracle's VirtualBox is free, and it has a lot of benefits. Obviously, reduction of cost, security, server provisioning, and of course, disaster recovery. If it's located in an off-site location and you have a disaster at your location, all the data is still there, which is nice. Your HYPER-VISOR or Hyper-V is your monitor to be able to manage your virtual machines. Again, you can have multiple machines working together, and your Hyper-V is going to be able to manage those. It can assign new virtual machines. It can look at the virtual machines, check them out, monitor them, make sure that they have the resources they need, make sure that they have the memory or the disk space that they need, and also be able to limit or quota them and make sure that they don't use up too much. So a lot of things being able to use with virtual machines. Again, I would expect in the real world, you're going to find virtualization more often than you're going to find servers in buildings. So a little bit of a short chapter for Chapter 9 on servers. The assignments that you're going to have to deal with Chapter 9. Again, you're going to have your review questions if you choose to do them, your study guide, and then your labs. So for your labs, 41 and 42, I want you to do them. They're going to be disk management, optimization, defragging. Those are good. Get familiar with your disk part command. which is going to walk you through the different ways the disks are defined. 43 and 44, if you choose to do them, go for it. However, 43 will add a new partition to your drive, which may not be an option that you have. You may not have enough extra disk space. You may not want to put a partition in. That's fine. You do not have to do the procedure for this lab. You can, if you want to add a partition, add a D drive in so you can store your game stuff on a different drive. That kind of stuff is fine if you want to go do that. What I'd like you to do is at least read through the procedure and do the review questions at the end. You do not have to do the lab to be able to do the review questions at the end. 44 is actively installing a RAID system. Again, if you have the opportunity to do this, great. Otherwise, just read over the directions and then answer the review questions at the end. So if you wanted to install a RAID system, you need a secondary hard drive. So you need to get an extra hard drive. You need the tools to install it if you're going to do it in a tower, or if you're going to do it in a box. And then you can run through the lab to be able to do that if you feel like installing it. Again, you do not have to. That is not required as a part of this course for you to damage your current machine by adding in a RAID drive. But again, if you felt like it, feel free. Obviously, the study mate's in there, and you've got your Chapter 9 quiz. So thank you so much for watching this video. If you have any questions, please let me know. Otherwise, have a great week, and we'll talk soon.